Section 10.9 is on graphs of proportional relationships. Jonah uses 16 gallons of water in an 8-minute shower. If he reduces his showering time to 5 minutes, how much water will he save? Use a graph to find your answer. So we could do this as a proportion. We could say it's 16 gallons for 8 minutes, and we're trying to find for 5 minutes. We could try to find a pattern here and figure that out. They do want us to use a graph, it says, so I guess we'll go with that idea. And part of this lesson is just going to be about, if we have a graph, looking at the graph and being able to interpret what the graph's telling you. So one thing you might notice, 16 gallons in 8 minutes, that can be reduced. So one thing we could do, we could make a table like the book mentions. Now if you do this, so it's 8 minutes for 16 gallons. That's kind of like the fraction 8/16, and that would reduce to 1/2. And you could have flip-flopped these. You could have had the gallons on top and the minutes on the bottom of your table. That part doesn't matter as long as you're consistent and as long as you keep track of what your numbers are supposed to be doing. So the book found these other numbers. So they reduced, first of all, and got 1 minute is 2 gallons. Some of the stuff in the middle here, though, is not necessarily maybe what we want to do. I'm going to show you a different way you could do this. There's nothing wrong with what the book did. Well, let me just make a separate table so you can look at both of these maybe. Okay, so what I don't like about their table is we're trying to find for 5 minutes. And if you look at their table, they have 1 minute, 2 minutes, 4 minutes, 6 minutes. They skipped the 5 minutes. So I'm going to do the table differently to where we exactly get 5 minutes. So the 8 minutes for 16 gallons reduced, 1 minute is 2 gallons. And then we can just keep adding on to that. So if we add another minute, we're adding another 2 gallons. So 2 minutes would be 4 gallons, 3 minutes would be 6 gallons, 4 minutes would be 8 gallons, 5 minutes would be 10 gallons. And that's what we're trying to find. Okay. Once we know that, the question is how much water would he save? So 16 gallons versus 10 gallons, that would be 6 gallons less. Or 6 gallons that he would be saving. Okay. Now, like I said, there's nothing wrong with what the book did. It's just that they skipped over the number that we were trying to find. So if you do it this way, what we just did, you'll be able to look at this, and then you can also graph it, and you can show the answer on your graph as well, which we'll look at next. So what they did is they used this table and they made ordered pairs, time, comma, water used. So we take this first part, 1, 2, 1 minute is 2 gallons, that becomes the 0.12. This becomes 2.4, and so on. Okay. And then they graphed this. They graphed all these points. You can see here. Also notice they labeled this. They labeled this water used in gallons, time in minutes. And then what they did is we're trying to find for 5 minutes how much water was used. So for 5 minutes they went right between the 4 and the 6 until they hit the line and then go straight across. That's right between 8 and 12, so that would be 10 gallons. Okay, which is what we found in our table when we did it a different way there. One thing to make sure of is if you are ever asked to draw a graph of your own, you need to make sure you have labels on the x-axis and the y-axis, or label the axes, they might say. Okay, they might also ask you to make a title. So the title, it could just be water use for a shower or something like that. So look at this practice question here. We've got an express bus that travels 150 miles to Washington, D.C. It makes the trip in 3 hours. What is the unit rate? So it's 150 miles in 3 hours. So the unit rate, there's different ways we might do this. And what you normally want to think about, if it doesn't directly tell you, we're going to normally do what the number first we're going to put on top, and then the second number on the bottom. Another thing you can consider is when you get the unit rate, what are your units? And is that what you're used to hearing or not? So if you divide this out, or if you think of dividing both of these by 3, 150 divided by 3 would be 50. So this is 50 miles per 1 hour, or we could say 50 miles per hour. Miles per hour sounds pretty familiar. If we would have switched it around, it would have been hours per mile. And I think that came out to like 200ths, so like 0.02 hours per mile. That's not normally how we hear things, so that's probably not what they want. So that's our unit rate. That's our answer to question 1. Number 2, describe what the unit rate means in the context of the problem. It's just telling us that the bus drives 50 miles every hour. And then number 3, they want us to name 3 equivalent ratios in the form number of hours driven, comma, number of miles traveled. What we can do is look at the table, look at the graph, and find some points. One of the points can be our unit rate we just found, which would be 1, 50. Remember, do x and then y. We can see another point here would be 2, 100. And a third point we could look, well, this one was already used. That was already given to us. Here's another point, 4, 200. And we could check these to make sure that they work if you divide them out. If you divide all of these out, you should get the same number because this is proportional. So you're going to get 50 for all of these when you divide them out. And one other thing, when you draw the graphs in this section, since they're proportional, they're going to be a straight line, and they're going to go through the origin. They're going to go through the point 0, 0. So that's another thing to watch for when you graph the problems in this section. Some of the things after this the book's talking about, they are going back to using tables and things, which we've already done in the past. So we're going to call that good for this section. So this gives you an idea of how to use graphs of proportional relationships. Have a good day.